So welcome to the session of JEE Bytes. Today we are starting with thermal properties of matter, students. So, hello Meghna, hello Wasim. So students, today we'll talk about some questions that have appeared in JEE and are related to the concept of thermal properties of matter. Yeah, hello Braj Kishore. So let's start with that. Yeah. So the question is, a liquid in a beaker has temperature theta T at time T, and theta naught is temperature of surroundings. Then according to Newton's law of cooling, the correct graph between log base E theta minus theta naught and T. So to solve this question, the first requirement is Newton's law of cooling, right? So now what is Newton's law of cooling? The rate of cooling of a body is directly proportional to temperature difference with the surroundings. And this is valid for small temperature difference between the surroundings and the body. For example, if there's a body and this body is radiating heat, and if let's say its temperature be theta and theta naught is the temperature of surroundings, so the rate of cooling is minus of d theta by dt, and that is proportional to instantaneous difference of temperature between them. So if a body is radiating heat, you should be clear about that theta must be greater than theta naught, right? So theta minus theta naught. So that means d theta over dt is equal to minus, or you can say minus d theta by dt is equal to k times theta minus theta naught, where k is a constant, right? So that's what is Newton's law of cooling is. Okay. So now let's read the question again and let's try to solve this question. Question says a liquid in a beaker has temperature theta T at time T, and theta naught is temperature of surroundings. Then according to Newton's law of cooling, the correct graph between log base E theta minus theta naught and T is. So we know that that d theta wait a while, d theta over dt is equal to minus of k into theta minus theta naught, where theta naught is the temperature of surroundings, right? And theta is the temperature of the body. Now, what we can do, we can take theta minus theta naught in denominator, and that's equal to minus of k into dt. Now, if you integrate both sides, what do you get? If you integrate both sides, you can easily understand that that's equal to log base E of theta minus theta naught. And here we have minus of kt plus c. So students, you can recognize this equation as the equation of a straight line like this. Y is equal to mx plus c. So that means log base E theta minus theta naught and minus kt plus c. So they represent actually a straight line having negative slope. Okay, so negative slope. So only one option is there, that's a straight line, and that's the option number A. So that's the correct answer. I hope all of you are getting this. That's quite easy if you're able to understand that. So now let's proceed to the question number 2. You can see the recording if you're not getting it. Okay. So Now, it's required that you should solve the previous year questions, because sometimes, you can get quite similarity in the questions of, successive years, right? Utsav d theta by dt is a change in temperature, rate of change of temperature. Okay. So now next question is, if a piece of metal is heated to a temperature theta and then allowed to cool in a room which is at temperature theta naught, the graph between the temperature of the metal and time t will be closest to. So again, students, this question that is based on Newton's law of cooling, right? So again, it's given that theta is the temperature of the body and theta naught is the temperature of the surroundings. So again, writing the Newton's law of cooling, what is that? Minus of d theta over dt is equal to k times theta minus theta naught. Okay. Or here theta is a temperature. So what we have to do, again, we have to do same thing. We can say d theta over theta minus theta naught is equal to minus of k into dt. Now, if you integrate both sides, again, you will get the same thing. Log of, or we can say log base e, theta minus theta naught is equal to minus of kt plus c. So basically, we need the graph between t and small t, temperature and time. In the previous case, we needed the graph of log base e, theta minus theta naught, and a temperature and a time. So in order to find the relation between temperature and time, we can say one thing, that theta minus theta naught is equal to e raised to power minus kt plus c. And we can say theta is equal to theta naught plus e raised to power minus kt plus c. So theta, now what is theta? It's a temperature. It is a temperature. And theta naught is the temperature of surroundings. Okay. So that's what we have to find, the temperature of the body as a function of time. Okay. So from here, we can understand that, see students, if you have learned about your graph of exponential functions, you can say e raised to power minus x. If y is equal to e raised to minus x, the graph is like this. Oh, sorry. Graph is like this. Let me draw it. It's like this. The kind of rectangular hyperbola. Okay. So, and now theta naught is there. So it will be a bit shifted by theta naught. So from the given options, we can say that C option is the most appropriate option. So that's a question that came in JEE Main 2013. Now let's proceed to the next question. An external pressure P is applied on a cube at 0 degrees Celsius so that it is equally compressed from all sides. So K is the bulk modulus of the material of the cube and alpha is its coefficient of linear expansion. Suppose we want to bring the cube to its original size by heating, the temperature should be raised by. So students, in this question, there are two opposite factors. One factor is external pressure. Okay, external pressure. So external pressure will compress the body. Okay, and the second thing is, the other part is increase in temperature. Okay, increase in temperature will do what? It will actually expand it. So what is given in the question, that how much temperature it should be raised so that it should come in original size. So students, in the chapter of your elastic properties of matter, you must have learned about simple thing like bulk modulus. What is bulk modulus? You see, K is a bulk modulus. It's equal to your volumetric stress by volumetric strain. Stress over strain, right? And here, that's volumetric stress and volumetric strain. So here, instead of stress, we can write pressure. And instead of strain, we can write volumetric strain like this, delta V by V. So K is equal to P by delta V over V. So what can I say? I can say that delta V over V is equal to P over K. This is equation number 1. Now let's talk about the other equation. Yeah, Rianshi, right. Pressure over strain. Okay. The second thing is increase in temperature. Let us say that let temperature increases by delta T. Okay. Let change in temperature is delta T. Okay. So we have learned that delta V is equal to V into gamma into delta T, and where gamma is what? Coefficient of volume expansion, right? So V into gamma into delta T. And in the question, we are provided with alpha. What is alpha? It's a coefficient of linear expansion. So we know a relation between gamma and alpha. We know that gamma is equal to 3 times alpha, right? So we can say delta V is equal to V times 3 times alpha into delta T. Okay. So delta V over V is equal to thrice of alpha into delta T. So from here, we have got equation number 2. So from equation number 1 and equation number 2, you can see that delta V over V has 2 values, P upon K and 3 alpha delta T. So what we can do, we can equate them, and simply we can write delta V over V is equal to P by K, and that's equal to thrice of alpha into delta T. Thrice of alpha into delta T. So in the question, we were provided that we have to find delta T. So this implies delta T is equal to P over 3 times alpha into K. That is the temperature raise, and you can see from the options is the option number B. That's most appropriate. Okay, students, I hope you're getting this. So such type of questions are very frequent in JEE. Let's see one more question of this category. So the pressure that has to be applied at the ends of a steel wire of length 10 centimeter to keep its length constant when its temperature is raised by 100 degrees Celsius. So same thing is given in the question also. Here also there are 2 factors. One is deforming force. Okay. One is deforming force, and that force is applied longitudinally. Shanu, you can just focus on this question. Okay. If you can understand this question, you will be able to understand the previous question also. And anytime you can see the recording. Okay. Shanu. Now, what is given here? here is a steel wire. Let's take the wire to be in cylindrical shape. Now its length is 10 centimeter, and we are applying, we are applying deforming force like this to compress it. Okay, and we are increasing its temperature by 100 degrees Celsius. So due to increase in temperature, now see, deforming force is trying to compress it. It's trying to compress it, and change in temperature, it's trying to expand it. So here also there are two factors that are opposite to each other. Okay. So in the question, if you read Sri, the pressure that has to be applied at the ends. So basically, in the question, we are required to find the deforming stress. Okay, what is pressure? Pressure is F upon A. And what is F? F is deforming force. Okay, try to understand that, Shri. So now, from simply, we can say stress over strain is equal to Young's modulus. And let's say that F is a deforming force that has to be applied. A deforming force that has to be applied. So F over A divided by strain delta L over L is equal to Y. And in the question, we are required to find pressure. So we can replace F over A by P. So we can say P is equal to Y, or you can say P by Y is equal to delta L over L. Let's take this equation as equation number 1. And again, we know that change in length when the temperature is increased by delta T is given as L into alpha into delta T. So from here we can say delta L over L is equal to alpha into delta T. Let's take this equation as equation number 2. So from the two equations, what we can say? We can say delta L over L is equal to P over Y, and that's equal to alpha into delta T. So in the question, we are required to find what? We are required to find P. So we can say P is equal to Y into alpha into delta T. So now in the question, we are given that Y, or Young's modulus, is equal to 2 into 10 raised to by 11 Newton per meter square, and coefficient of thermal expansion is alpha, and that's 1.1 into 10 raised to minus 5 per Kelvin. That's your alpha, and that's your Young's modulus. So you can put the values in this expression that we have got. So P is equal to, simply, if you substitute the values, what are the values? Y is equal to 2 into 10 raised to by 11, 2 into 10 raised to power 11 multiplied by alpha, and that's equal to 1.1 into 10 raised to power minus 5 and multiplied by 100. So if you multiplied them, you'll simply get 2.2 into 10 raised to power 8 pascals. That's the pressure that has to be applied in order to just stop the chain in the length of this given wire. Okay. So now let's see the other question. So on the other question, it's given that two conducting cylinders of equal length but different radii are connected in series between two heat baths. So these are here heat baths. Okay, these are heat baths. This one and this one. The radius of the bigger cylinder is twice that of the smaller one. Okay, let's take this, the radius of the smaller one to be small r radius, and other one will have 2 into small r as a radius. Now K1 and K2 are the thermal conductivities of the rods, the cylinders. So if the temperature at the junction of the two cylinders is 200 Kelvin, let's say T naught is equal to 200 Kelvin. So in the steady state, okay, it's given that in the steady state, it's 200 Kelvin. Then K1 by K2 is. So students, you should know what is steady state. Suppose this is your rod. So in this rod, you can see at a steady state, the rate of flow of heat is constant throughout the medium. Okay, so what we can say, like dq by dt is constant throughout the medium. If this is a rod, throughout this dq by dt should be same. And the formula for dq by dt is equal to k times T1 minus T2 multiplied by area of cross section divided by length. If length of this is small l and the area of cross section is a, so you can say dq by dt is equal to k into T1 minus T2 into a by l. That's what is dq by dt is. So now let's see the question. In the question, we are provided that there are two cylinders having different, you can say, radii. Okay, so what we have to do, we have to apply this formula that dq over dt. Now dq over dt is same for both cylinders. So dq by dt is equal to how much? It's equal to k times a. Let's take it for first cylinder. So k times T1 minus T naught divided into area of cross section. What is the area of cross section? It's pi r square, because r is a radius. So pi into small r square is a radius, sorry, area, divided by capital L. That is what dq by dt is. Okay, for cylinder 1, first cylinder. And for second cylinder, dq by dt is equal. Now see, in this case, we are given that it's k1. And for the second one, it's k2 multiplied by T naught minus T2 over L multiplied by pi into 2r square. So now we'll equate them. This one is for second cylinder. Okay, cylinder 2. Now what we'll do, we'll equate them, and simply we can say k1 multiplied by T1 minus T naught into pi into r square divided by capital L is equal to k2 into T naught minus T2 into pi into 4r, or you can say simply 4 pi r square, and divided by capital L. So simply we can just cancel out this L and pi and r square. So now in the question, it is given that T naught is 200. So T1 minus T naught, it's again 300 minus 200. So it's 100. And again, T naught minus T2 is also equal to 100. Because T naught is 200 and T2 is 100, right? So from here, you can say T1 minus T naught, see, it should be K1 multiplied by 100 into, and okay, everything is cancelled, and K2 into 100 into 4. Again, 100 and 100 also get cancelled. So from here, we can say K1 over K2 is equal to 4. That's the answer. That's the final answer of this question. So student, thank you so much for attending the session. We hope you all the very best for your preparations. For more information, you can see the link that's given in the information. Okay. So thank you so much. So all the very best.